Hi, welcome back to Physics Teacher. This is a question from the Euclid contest, which is the grade 12 math contest from Waterloo University. And here we have a rectangle and an equilateral triangle. And we know that AE is 2x, so this length here is 2x. Now the first part asks to find this length, AB. And then the second part asks to find the ratio between AC and AD in order to determine what these two values or these two integers R and S are. Give it a try and I'll be right back with the solution. Alright, so let's start with the first part. What I'm going to do is I'm going to draw AD here. I'm going to connect A and D so we can visualize this. And now it does say that AD is parallel to BC. So this line is parallel to this line. And since this is an equilateral triangle, that means this is 60 degrees. And since those two lines are parallel, that would mean that this is also 60 degrees. So what we have here is A, B, and D form a 30, 60, 90 triangle. You may remember these triangles from your special angles in trigonometry. Let me draw another one. So let's take a 30, 60, 90 triangle where you have, here's your 60, and we have side lengths of 1, 2, and root 3. Alright, and this triangle is similar to this triangle. So what I can do then, since AE is 2x, BD is also 2x, so I can compare ratios. And I can write 2x over 1 is going to equal AB over root 3. Then, solving for this length AB, we just get 2 root 3 times x. So there's the first part done. There's I. Okay, well let's look at the second part. The second part says to determine positive integers R and S for which this ratio is the square root of R over S. So this is AC over AD. So let me draw AC in here. Use a different color here. And then what I'm also going to draw is I'm going to take the midpoint here between A and E. So let's call that M for midpoint. And I'm going to connect that straight over to C. Let's call this would also be the midpoint of BD. Let's call that N. And since the whole thing, AE is 2x, that means just A to M would just be x. Similar, B to N would also be x. And so let's look at this triangle then here. BNC. That is another 60, 30, 90 triangle, where I know that BN is x. Alright then. So I can use this to actually figure out what this length NC is. Same as before, we are going to do a similar triangle and compare ratios with this one here. So I can write NC over X equals root 3 over 1. And so solving for that length NC, I get the root 3 times X. So now that I have NC, I can figure out what MC actually is. Because MC is just going to be M to N, which is the same length as AB, which I found in part 1. So that is 2 root 3 times X plus NC here, which I just figured out is root 3x. So if I add those, then I know what MC is. And you'll get 3 root 3 times x. So now I can start looking at this ratio. So let's start figuring out what AC is. So if we look at this triangle, AMC, that's a right angle triangle. And I know that this side is x, and this length is 3 root 3x. So I can figure out AC just by using the Pythagorean theorem. So AC is going to be the square root of 3 root 3 times x squared plus x squared. Okay, so 3 squared is 9 times by the root 3 of squared, which is 3, so that's going to give us 27. So we have 27 x squared plus another x squared is 28x squared, or we can reduce that to 2 root 7 times x. I can do the same thing to find out what AD is. I can use the Pythagorean theorem for this triangle. So here I have 2x. So this is going to be the square root of 2x squared plus ED, which is the same as AB, which was 2 root 3x. So 2 root 3x squared. And that is going to simplify. So we have 4x squared, and here we have 4 times 3, so 12x squared. Adding 4 and 12, we get 16x squared, or just 4x. So now I know what AC and AD are. So let's figure out what that ratio is then. AC over AD will equal, so 2 root 7 x over 4x. So the x's cancel, and 2 over 4 just gives us root 7 over 2. But since I want to change it to look like this, I can change 2 to be the square root of 4, and that just gives us the square root of 7 over 4, which would mean R is 7 and S is 4.